Welcome everyone. My name is Dr. Bishal Diyali. I'm an assistant professor in the School of Applied Sciences and Humanities, Haldia Institute of Technology. Today I'm going to give a small lecture on the introduction of statistics as a subject. Without wasting much time, let us start straight away. First we want to know what is statistics. Okay, statistics is a branch of science that deals with the collection, representation, analysis, and interpretation of data. Okay, today in this world, if we see every field, everything has lot of data with them. If you go to some organization, they have data of so many years. Okay, if you go to financial institutions, okay, they have reports of finances from so many years. So if you go anywhere these days, everything is flooded with data. So it is very important to use those data. And statistics is doing all those things. Okay, we are analyzing data and we make use of those data to make good decisions for the futures or to analyze the risks. Okay, so data are used for so many things. Okay, so the best thing that we use data is to make good future plan or to do good prediction or to analyze risks or reduce the risk. Okay, there are so many applications of the data analysis. Okay, so everything that is related with data uh, can be helped by the use of statistics. Okay, and data scientists, data analysis. Okay, all these things are directly related with the statistics. Statistics has application in almost every subject of the world. Okay, uh, maybe it has not much uses in the literature, but still literature can also use statistics for historical experiments and all. Okay, let us not talk into this. If you talk about the traditional sciences like chemistry, physics, mathematics, biology, okay, every subject is incorporating statistics, okay, because they have to analyze data, and the scientific way of analyzing data is the statistical methods. Okay, if we talk about chemistries, they are already using the concepts of probability and uncertainties in the atomic structures. The Heisenberg uncertainty principle is completely based on the probability theory. Like in physics, you can see there is a branch of physics which is called statistical mechanics, and a lot of physicists are working these days on the extreme value statistics, which statisticians are not even working as much as the physicists are working. So and mathematics, there is already a branch of probability, measure theory. So a lot of things are going on in the traditional sciences also. Okay, uh, I'm not talking about biologists because in biologists also there are a lot of uses, and I'm not much aware of those things. In medicines, okay, there is a branch of medicine that is called evidence-based medicine, which use the concept of experimentation and statistical validation for using the medicines. Okay, and whenever there are new drugs, okay, it has to be implemented using the statistical designs. So in medicines, a lot of things are related with statistics, and they have to study statistics a lot. Epidemiology, they study epidemiology, evidence-based medicine, so a lot of things. If you talk about actuarial sciences, if you talk about insurance markets, financial markets, health markets, okay, the companies who are giving insurances, life insurances, health insurances, accidental insurances, they are selling those insurances based on their analysis of risk. Okay, they know what are their risks, and what are their gains. So without statistics, nobody can do those type of business. Okay, they are very, very clever, and their analyses are always good. So the insurance companies, they hardly go through losses because they know what they are doing. They have full control over their risk. Okay, and those things can all be done by using the help of statistics. If you talk about cosmologies, okay, every day a new star is getting discovered. Every day some exoplanets are getting discovered. Something is getting discovered every day, okay? Every day new things are coming up in the sky. Means they are already there, they are getting noticed or something. Some structures are getting studied, okay? And there is a concept of statistics called clustering, hierarchical clustering, k-means clustering, and every time we look into the sky, okay, the researchers, they always try to look for the clusters, galaxy clusters, voids, okay, cluster of like small cluster, large clusters. So with the help of those clusters, we can identify some fundamental things that is going on in the cosmos, okay? And statistics has been fundamental in the discovery of many things that is going on in the cosmos, and in the coming years also statistics is going to play a very vital role. Uh, okay, in government also. Let us talk about government of India. Every 5 years, our government pass 5 year plans for the development and growth of the country. Okay, and how do they come up with those 5 years plans? They analyze the data of the people of the country, of health, of economics, of jobs, okay? Everything. They study those data. Okay, there are a lot of statisticians in the government. There is Indian Statistical Services, okay? They are highly intellectual statisticians. They they study the data of the country, and they give those analysis to the economist. Okay, there is another branch, Indian Economic Services. So based on the analysis done by the statisticians, those economists of our countries, they frame plans for the growth and development of the country. Okay, without statistics, no country can progress for in a good direction, because everybody needs to know their weaknesses and their powers. Okay, we have to reduce our weaknesses and we have to increase our power, and it can, for any nation, it can be done with the help of statistics and the data analysis of the country. Every time we talk about statistics, we have to know about the two things. One is the population and another is the sample. Population is population is a well-defined collection of distinct elements or objects. Okay, it can be the population of stars in the sky, population of tigers in a forest, population of fishes in a pond, population of trees in a forest, population of insects in the world, population of giraffes in Africa. So it can be so many things, okay? But it has to be distinctly defined, okay? It doesn't have to be the totality of everything. It can be certain section that is considered as the population or as per studied, and there is a sample. Okay, every time we talk about population we have to talk about the sample, because it is not possible to study the population completely. Okay, uh, we have to take a part of the population. We we take a part of the population and we study it, okay, in order to make some analysis and inference about the whole population. Okay, so sample is very, very important. With the help of sample, we try to know about the truth about the population. Okay, like suppose the population is the uh, the entire population of the skies in the galaxy. Suppose we want to know about the total number of stars in the sky, okay? And we cannot count every star. We have to look at the certain section of the sky, and we have to use some statistics to estimate the total number of stars based on that certain section of the sky. Suppose we want to calculate the total number of tigers in a forest, then we have to look at a particular area of that forest and we have to observe the tigers in that forest, okay? And there are so many things. So let me give an example of how population and samples are used in statistics, okay? So in this example, we are we are interested in estimating the total number of fishes, okay, in a pond on any particular day. It can be any pond or it can be any day, okay. On certain day, suppose that you want to go and calculate the total number of fishes of your nearby pond, okay. So you don't know the total number of fishes. So first, you can do this in three steps, okay, with the help of statistics. So first you have to catch some fishes and mark them all the fishes that you caught on the first time, you mark them all, okay, count the total number of fishes and throw them again in the pond, and after throw them into the pond, and in that way we will know the total proportion of the marked fishes in the pond, okay, is given in the step number one, capital M by N. Then after that step, we again catch another set of fishes from the pond, okay? Let that be small letter n. It would be the sample, okay? And in that sample, we'll have a mixture of the marked fishes which we caught in the first time and the fishes that were not caught in the first time, okay? So from that step, we'll be able to know the proportion of marked fishes in the second sample, okay? So we equate equation 1 and 2, okay, we compare the population and sample proportion, and through that we will get some approximate value of the population of the fishes, which is given by n equals to small letter n into m divided by x. You can see that all the terms in the right hand sides are already known to us before from the start of the experiment, okay? We make sure we know all of those things. And through that way, we can calculate the number of fishes. In the similar way, we can calculate the number of tigers, number of stars. So it ha the process, the method may vary, okay? We have this marking here. Some other kind of techniques can be used, but statistics will be used, okay? And it is used to know the value of the population parameter. Maybe population total, population mean, population standard deviation, population variance, population variance. There can be so many things about the population that we want to know, okay? And the only way to know about them is to do the complete study of the population, which is impossible, or study a certain section of the population as a sample and try to infer for the population, okay? After this, we have to before we go into statistics, okay, before we study statistics, it is very important for us to know what are the divisions of statistics, because every subject has some division among themselves, okay. And statistics is broadly divided into two parts, only two parts, okay. It may have different parts under them, but we only have two divisions in statistics. One is descriptive statistics and another is inferential statistics, okay? By the term descriptive, we mean that everything that is used to describe the data sets or describe something, describe Okay, describe data. So all the concepts that are used in describing and presenting datas, okay, those things comes under the descriptive statistics. Like suppose we have a data set, we want to know about the location of the data set. Then we'll calculate the mean, median, mode, arithmetic mean, harmonic mean, okay, everything that is related with the location of the data set. Through that, we'll be able to know about the where is the location of the data, means where is the central value of the data, where is the concentration of the data, okay, that is the location. And after that, we want to know about the scale of the distribution, okay, how much data is spread over the region or over the scale, okay. So for scale, we will be calculating quartile deviation, range, standard deviation, root mean, square deviation, variance, okay, coefficient of variation, so many things for scales, okay. And these all things are used for describing data sets and shape parameters. If you want to talk about shape parameters, then we can calculate skewness, kurtosis, moments. Okay, those things all gives the ideas about the shape of the data or shape of the distribution of the data. Okay, data sets. So everything that is used for describing data sets can come under the descriptive statistics. Okay, we'll discuss it in detail in the upcoming lectures. Okay, I just wanted to introduce a little bit of statistics in this lecture. Another part of the statistic division is the inferential statistics, and inferential statistics in itself is very big and it has two broad division in itself, okay, which are very big in themselves. One is the estimation. There are so many types of estimation. There are so many classes of estimations, okay. We'll discuss it later. And another is the testing of hypothesis. So estimation always deals about the estimating the parameters of the population. It can be anything, mean, median, variance, okay. Anything that describes the population is called the population parameter, okay. And we want to estimate those things because we don't know the true value. So we have to use some approximate value and we want to approximate it in such a way that it is good and it is based on a sample. Okay, so we study a sample and we estimate the parameter of interest from the population. Okay, and after we do the estimation, then we have to check whether those estimates are valid, whether those estimates are reliable. Okay, and that is done by using the testing of hypothesis. Okay, and testing of hypothesis has a lot of application, not just in statistics. Okay, every quantitative research, every PhD where the quantitative research or qualitative researches are considered, they do a lot of testing of hypothesis for their research questions. Okay, so we'll discuss it more in detail in the upcoming videos. This is just a basic introduction of or the overall view of the subject, okay? This is a very different kind of introduction because I want to take you guys in a very different path, okay, of statistics. And I want all of you to enjoy studying statistics because statistics is very fun to understand, hard to implement, and easy to use. So these are some books that you guys can, that anyone can follow for studying statistics. Fundamental of Statistics is the best book I've ever come across. That is my favorite book. It has everything that anybody wants to know about statistics. Outline of Statistics is also very good. It's by the same author. Okay, it has most of the applications of the statistics. If you read those four books, then your knowledge on statistics will be complete. The book's knowledge will be complete. If you want to do research, then you have to read about the researches, current trend of researches, okay? But the textbook knowledge of statistics will be complete by these four books. And if somebody is not from statistics background, okay, if they are from other subjects, then they can go for the third book. That is specially for the ones who are not from statistics. So, and thank you very much. I hope you all enjoyed my lecture. See you in the next one. Until then, take care and bye bye.